Okay, everyone, back with example 2 as if example 1 wasn't enough on its own. And we are here with a real world example that really definitely fits our valley. And so a quick opening story to this one. Sometimes if you drive around the valley, you will see corn planted everywhere. Other times you will see cornfields ripped out and have hops put in or have alfalfa put in. And it's because farmers are limited by things like fertilizer, herbicide, labor, and other times because certain products are worth more to sell in the market at that given time. So this problem, again, fits very well with the valley and is actually something that you could run into if you get involved with business locally. So again, first thing to keep in mind, everyone, as we do start example 2, is our first step is to look for the totals as we see them in the problem, and we're going to write them down and label them as we see them. And so right off the bat, we have a farm co-op that has 6,000 acres available to plant with corn and soybeans. And so to me, that sounds like a total, so I'm going to go ahead and throw that down. That's going to be 6,000 acres. And for me, just help me keep myself organized, I'm going to draw a line there to separate my lines of inequalities. So we keep an eye out for totals again, as I mentioned, everyone. Each acre of corn requires 9 gallons of fertilizer, herbicide, and 3/4 hours of labor. That doesn't sound like a total. Each acre of soybeans requires 3 gallons of fertilizer and herbicide and 1 hour of labor. That doesn't sound like a total. Each co-op has available at most 40,500 gallons of fertilizer and herbicide. That's definitely a total. So I got that one. And at most 5,250 hours of labor. The number of acres each crop is limited by the available resources and labor. We're asked to write a system of inequalities that describes the constraints and find the corners in the graph. And so as I mentioned, everyone, again, the first step is to go through the problem. You may have to read it 2 or 3 times, find the totals, label them, as I have here. Then we're going to go back and try to fill in what our 2 columns are going to be. So each acre of corn requires 9 gallons of fertilizer, herbicide, and 3/4 hours of labor. So 9 fertilizer for corn, and I'm going to put in 0.75 instead of 3/4 for hours of labor. So right now, by putting X on those values, everyone, I'm defining that X is going to be the variable that I'm using to represent corn. And I'm not sure about acres yet. We'll talk about that conversation in a moment. And it says that for soybeans, we need 3 gallons of fertilizer and 1 hour of labor. So 3 gallons of fertilizer, soybeans will be our Y value, 1 hour of labor, and so soybeans goes here. Let's talk a little bit about acres because it's still blank. A farm co-op has 6,000 acres available. So since there's no more information there, we can assume it is just like what we did previously, where some of the money plus some of the money is equal to all the money. So we can put X plus Y there. What we're really saying there is we don't know how many acres of corn and how many acres of soybeans. We just know that there are 6,000 acres available and that's going to be distributed somehow. So as we think about the inequality symbols for these, everyone, we need to understand that they have at most 40,500 gallons. So we need to use less than that much fertilizer. If we use only 20 gallons, it's fine. If we only use 20,000 gallons, it's okay. We just can't go over the 40,500. Same thing with the hours, everyone. We have to be less than or equal to that. And obviously we only have so much land, so we need to be less than or equal to that. So just recapping, what I do first when I approach these problems is I find the totals and label them. Then choose one of the things that I think is going to be a column and put those values in place. If that works out well, find the other thing that should be a column and fill in those values as well. So what we've got at this point, everyone, is we have 3 inequalities that we are going to be graphing in GeoGebra. And if you have your graph from the previous problem up here, again, the way to fix that is to click these 3 bars right here. You could export the image if you wanted to export a picture of the graph that you currently had. Or you could click New, and it would ask you if you wanted to save what was there. You would just say Don't Save, and then it would bring up a brand new sheet for you, as it has for me right here. So again, everyone, I'm just going to copy my equations in here, or my inequalities in this case. And you'll see that I see a lot of purple. To fix that, I need to zoom way out, because obviously 1,000 and 1,600 is way less than 6,000, so we're going to be way off the grid. And remember, you can only move the grid around if you have your cursor on the white area. It's not going to move if you put it on the shaded area. My other two equations, everyone, are 9x plus 3y is less than or equal to 40,500. My final one is 0.75x plus 1y is less than or equal to 5,250. So as we mentioned before, everyone, we are looking for corners, specifically corners where where it's at the darkest part of our shaded region. So you can see I've got light here, darker here, darkest here. I'm looking for any corners, and again, we consider the x-axis and a y-axis to be part of this. This is a corner right here that abuts the darkest region. I've got a corner right here. I've got a corner right here. And I've got a corner right here. So there are going to be 4 corners that we can take into consideration for this farmer to try and figure out what the best use of the resources of land, fertilizer, herbicide, and labor are. In order to get those points on there, as I've mentioned before, we need to recreate these 3 inequalities, but this time we need to turn them into equations so that there's actually a line on GeoGebra here, and GeoGebra recognizes it as a line. So again, very simply, I just duplicated those 3 inputs. You could type them by hand if that was something that you really wanted to do. And I'm deleting the inequality symbol and putting in an equal sign. So you can see here in GeoGebra that GeoGebra took what I gave it and changed it to something else. It's because GeoGebra is just dividing and simplifying this. Pay no attention to that. Just make sure that you put it into GeoGebra correctly the first time, and everything will be all right. Again, as I mentioned before, we need a line on our x-axis and we need a line on our y-axis. So to do that, we will have an x equals 0 and a y equals 0. So now I've got a line here, a line here. The shading was already done. I've got a line here, and a line here. Now I can come here to this button and get my intersect. And again, I'm only going to consider the points that touch, or the corners that touch, the darkest region. So there we have points A, B, C, and D, everyone. I'm going to record those on my iPad while I talk through what those points mean. And I'm going to just kind of pull my iPad off to the side here so that we can see. So again, we did label X. We assigned X to the corn and Y to the soybeans when we created the inequalities. So I'm just going to list these points, everyone, so that I can test them to see what's going to be the best option for this farmer. So one option is 0x 5,250y. And you'll notice here, everyone, this means no corn gets planted and soybeans get planted on 5,250 acres. You might be thinking to yourself, well, why don't they do all 6,000 acres with soybeans? The answer is because that's not a viable option. Because even though we have the acres, we are either lacking in fertilizer and herbicide or enough hours to be able to harvest that. So this is taking into consideration the acres, the fertilizer, and the hours. And if one of them is lacking, it limits the amount that we can plant. So we're going to call that option A, everyone. Option B is 3,000 and 3,000. I'm going to erase that comma really quick so it doesn't get confusing on us. So 3,000 and 3,000 is option B. Option C is 3,750 and 2,250. And I know it's difficult to see on my iPad. We got 4,500 and 0 is our last one. And so again, please do notice with both options A and D, we do not plant all 6,000 acres of land because we are either lacking enough fertilizer or enough hours to produce or harvest the crop. And so again, this is taking into account that if we were to try to only plant one of those, in this case only soybeans and in this case only corn, we would have some land that is sitting doing nothing because we don't have enough, again, fertilizer or hours to make use of the land. So we have gone through the process of constructing kind of a complex system of inequalities for this, putting that system of inequalities into GeoGebra, finding the corners of that, and that's all we are asked to do for example 2. We'll be back for example 2 continued in a moment, and we are going to have some advice for this farmer as a result of the next video. With that, everyone, I hope that these are making sense. Please take the opportunity to watch the video as many times as you need to get this right. I recognize that this is a little bit difficult to do virtually.